Hi, I'm Rick Dunkel. I'm with the American Seed Trade Association, and I serve as the Senior Director for Seed Health and Trade, which means I deal with the phytosanitary issues associated with international seed movements. Specifically, that means that seeds can serve as a pathway for moving unwanted pests and diseases around the world. And so our goal is to keep all seed clean from any of these unwanted pests and diseases.
I've been working as a plant breeder for more than 30 years, and we're employing a lot of molecular technology to identify our material, to characterize it, to evaluate and to assess materials coming into the program, whether they're breeding lines or hybrid varieties that we're developing. Genetic purity is really a complicated process whereby we maintain the uniformity, the seed health cleanliness of all of our breeding material going through the process. One of the ways that we ensure genetic purity is through our controlled pollinations. We do those inside of a cage structure, and that gives us protection against outside insects, against maybe any disease that might be present in the open field. The procedure for that is actually to identify female flowers on the melon plant, and we prepare those in the afternoon for pollination. And the next day, a team of highly skilled pollinators will come into those areas and will actually prepare the flower some more. It's interesting because bees are doing the same thing in the open field. They're moving pollen around, but we're trying to control it so we control the purity and the identity of that specific line or plant. The other thing that we take care of when we're in those cages is sanitation. We take it extremely seriously for a variety of important reasons. So the process of the self-pollination is a very important one, and it really ensures the forward movement of our breeding material and the uniformity and purity of it.
So the way we determine risk of a pathogen or a pest is to first determine where that seed came from. If the seed was produced in a country where there are a lot of endemic pathogens that we know are going to be a problem, then we'll test it or grow the plants up in an isolation zone and test the actual seedlings to be sure that they're disease-free before we release them to be planted on the station.
Before we start planting a crop, the first thing we do is site selection. Some crops like heavier soils, other crops like lighter soils, so it's a determination depending on what crop you're growing. The other thing that's very important about the site selection is your rotation in the field. If you have proper rotation in the field, you usually will prevent a lot of the disease problems that you can potentially have.
There are a lot of things that we do to prevent outbreaks of seed-borne diseases on our research stations. It really starts with the people, because we have to have the people on the ground, people that are actually doing the job, keeping their eyes open and watching out. So that's the first line of defense.
Every time you approach a field, in my mind, I'm doing a mini risk assessment. I'm looking at points of entry, wind direction, low spots in the field, areas where potential risk or disease could enter the field. Now we're making the assumption our seed is clean, and with our seed testing program we feel strongly that it is, but at the same token you have to look at all the other possibilities. What could be the source? You don't want to cluster all one crop within a block. You've enhanced your risk for an outbreak. My focus approach is where's the highest likely a disease can enter a field. Borders, the side where the predominant wind is coming in. Entry points, equipment or people. Is hygiene or protective clothing being worn? All these are factors in introducing a disease into a production. We're up against situations that nobody's been exposed to before, oftentimes. And trying to find how the outbreak occurred is critical for us to make improvements in our production practices.
We're doing a lot of post-harvest assessments to see how material does in transportation, but also there's a lot of image analysis technology coming in that is really going to revolutionize this industry in terms of taking images or using phenotyping carts in the field that will do a lot of phenotyping for traits that may be too tedious or time consuming for us to evaluate. So I think the advancements in terms of many areas of technology will be a big benefit and will really revolutionize the way that we're currently working in the years to come.
I think what makes our lab so special is the commitment to following those standard methods to finding the pathogen in the seed, working and collaborating with other universities or industry testing groups that help us develop the methods that enable us to deliver the best seed health test. We focus a lot on technology and implementing new technologies. Most of the time, the technology is used to increase throughput or efficiency. So in a lot of our ELISA and PCR testing, we will use automation to perform the dilutions, add chemistry to start the PCR ELISA assays. It allows us a much higher throughput, and it reduces ergonomic stress in the lab from pipetting. In the lab, we actually have to grind seed, and the reason is that a lot of the pathogens that are vectored by seed aren't necessarily on the outside, but they're also on the inside. So grinding allows us to release those pathogens when we add them into buffer. So our lab is accredited for a number of seed health tests. There are several testing groups that enable accreditation or authorize accreditation. The National Seed Health System is a group that authorizes us to be accredited for seed health testing, and these accreditations are really important because seed is moved all over the world, and many of the countries where we move seed require seed certification that these seeds are free from certain pathogens. The accreditation that we receive through the National Seed Health System allows us to issue certificates to support the documentation to export seed.
So one of the first steps in the seed process is planting of the seed. The first thing that we do is go out and look at how the bed is prepared. What we also do just before planting is be sure that the seed that we're going to plant is in a sealed container and has all the necessary disease testing done. Then when we're ready to plant, we bring the planter out, and before we put any seed in the planter, we make sure that it's completely clean and devoid of any existing seed in the planter. Prior to harvesting of a seed crop, the first thing you have to do is to be sure the maturity of the seed is proper. Once you've determined the seed is mature, then it's time for harvest. So when we move the machine into the field, the proper calibration is very important. The watermelons that are being harvested are actually crushed in the crusher up above, and it exposes the inside of the fruit to what we call a drum, and the seed goes through the drum and into a coner screen, which takes all the juice out of it. So that cleans the product as clean as we can get it in the field. It's important to try to have it as clean as possible going from the field to the washer dryer, but it's a fine adjustment that you have to make. The seed goes through a washing process, a screening process, and comes out the other end fairly clean. After the seed crop is dried, the seed actually is tested for the moisture from a seed moisture tester that has to be calibrated every year. In each step where the seed moves along this chain, the seed is identified by a seed tag, is what we call it, and the tag is identified by the lot number of the field and also the grower. Then when the seed comes out of the dryer and goes into the bin, not only is the bin tagged on the outside, but there's also another tag placed on the inside of the bin.
In addition to using a lot of these same practices in the commercial field increases, the tracking that is done for those fields is extensive. Whether it's a big field increase done here in the US or the small hand-pollinated productions that are done overseas and combined into larger seed lots, every little seed increase has its own unique identity, and blended lots, it's known what are all the components that have gone into that blended lot. This is important for us because if seedborne disease is detected, we want to know the areas where the location or the production practices are an issue for future years.
So when you're utilizing disinfections, it's very important to have a repeatable process. So for us, precise recipes that ensure that every time we utilize disinfection on a specific species, the result is always the same and we're always following the same protocols.
Sanitation is really important to us because we want to be able to produce clean seed for what we're selling to our customers. And we put a lot of effort into things like separating breeding activity and product development activity from our seed increases, spraying down people who are entering the cages where seed's being grown, testing plants and inspecting seedlings before they get used in the field, and then running disinfection and seed assays on those seed stocks that we increase. We want to have very clean seed to start out with when we go into our commercial production fields, because that really increases the probability of having really clean seed that we sell to our customers. Phytosanitary field inspection is a significant component of producing the clean seed. We do it both ourselves with our pathology personnel, but we also partner with county and state government officials here in the U.S. or the other countries we're producing seed in to have more eyes on the field to identify diseases that could have moved into the field, and again, do everything we can to make sure that seed we start out with is clean.
In the small seeded vegetables, we utilize presumptive or precautionary disinfections to eliminate chances of bacterial and virus infections on the seed. So it's a complement to the practices taken when you're growing the seed to ensure that we're delivering a high quality, disease-free product to the end market.
So the U.S. government has been working with the seed industry, been working with our international partners through international forums in developing systems approach designed to produce seeds that are free from pests and diseases, but also ensuring that we have consistent application of phytosanitary requirements. The most important thing any country can do is to implement the international standard for seed movement.
We're learning that these practices themselves are significantly reducing phytosanitary risk. It's one thing to just say that, but how do you prove it? And so for the past several years, ASTA has been supporting a research effort to develop a phytosanitary risk reduction estimation model. It's a model that can actually evaluate these practices by themselves or in combination and actually estimate what risk may be remaining. And it's relatively new science to be able to quantify expert opinion and at the same time consider scientific data where it occurs. And so we'll be able to take that model, run their current practices through that model, and estimate what risks may be left. And from a regulatory perspective, we need to demonstrate this as much as possible to the regulatory community, because what we all have in common is if there's any significant risk remaining after these practices, what is it and what do we need to do to address that? Because that's where the innovations really begin to occur. As you can see, this is truly a global industry, and we all have to work together to establish harmonized practices around the world. This will facilitate the international movement of seed and reduce the uncertainty in that trade environment for all trading partners.